evening, everyone. I'm Manushri, and my teammates are Bhumika, Anu, and Avani. Today, we are going to present topic about smallest of three numbers, and I'm going to do introduction and objectives. Introduction: Assembly language programming for the 8051 microcontroller allows direct control over hardware components like registers, memory, and the CPU. Unlike high-level languages, assembly works very close to the machine, helping us to understand how instructions are executed step by step. In this program, we use basic comparison and branching instructions to identify the smallest value and store in three different memory locations. This helps us to understand how the microcontroller handles decision making at the binary instructions level. And next we have objectives. To design a simple assembly program that compares values stored in specific memory locations, to understand how the 8051 use the accumulator and flags during comparisons, and to learn the use of conditional jump instructions such as CJNE and JC for making logical decisions, and to determine the smallest value among three numbers and store it in another memory location, and finally to improve understanding of low-level CPU execution, memory manipulation, and instruction flow.
I'm going to explain about abstraction and problem statement. So, the core concept of abstraction here is transforming a series of low-level machine-specific instruction into a single understandable logic operation. Finding the minimum value or smallest of three numbers instead of detailing the complex sequence of actions such as loading the value from memory 7EH into the accumulator, moving it to register B, loading the next number from 7FH into A, performing an unassigned binary subtraction via the CMP instruction, and then checking the carry flag to decide if a conditional jump to skip one should occur. The programmer abstracts all these steps into a simple logical comparison: is N2 is lesser than B if S update B to N2, or register B itself serves as an abstraction for the smallest number found so far. The ultimate abstraction is that the entire assembly code block represents the mathematical function result, that is, result is equals to minimum n1, n2, n3, allowing a user or higher level programmer to utilize this code without needing to know the exact 8085 instructions, registers, or memory management involved. Coming to problem statement, for this, assembly code is to efficiently find the minimum value among three 8-bit unassigned numbers provided in memory and store the result in a designated memory location. Specifically, the program must retrieve the input values from addresses like 7EH and 7FH and 80H, perform a series of comparisons, and then deposit the smallest unidentified value into memory address, that is 81H. The algorithm employed is a simple sequential comparison where the first number is assumed to be the smallest initially, and then the second and third numbers are compared against this running minimum, replacing if it is a smaller number is found. The concept of abstraction in this context allows us to view the complex sequence of low level assembly instruction as a single higher level logical operation where result is equals to minimum, as I said, N1, N2, and N3. This hides the intricate details of how the microprocessor physically performs subtraction, checks the carry flag for the less than condition, and conditionally jumps to different parts of the code. Instead of dealing with registers and flags, a programmer can simply state the goal, that is to find the smallest of three numbers, relying on the assembly code to implement that abstract function. Next is continued by Anupatil.
Implementation. The program begins execution from memory address 2000H. The first number is loaded from 7EH into accumulator and copied to register B. The second number is loaded from 7FH and compared with B. If small number, it is retained in B and B is updated. The third number from 80H is then compared with current smallest in B. Again, B is updated only if the new value is smaller. Finally, the smallest number stored in B is moved back to A and saved at memory location 81H. The program then adds using the HLT instruction result. The smallest number among the three values from 7EH, 7FH, and 80H is stored at memory address 81H. Execution: the program loads the first number 25H into the accumulator and copies it to B. The second number 40H is compared with B. Since 40H is greater than 25H, B remains 25H. The third number 10H is compared. Since the 10H is less than 25H, B is updated to 10H. The smallest value 10H is stored in memory location 81H. Final output memory address 81H is smallest number is equal to 80H. That is disassembly windows shows execute instruction from by instruction execution. The registers panel A, B, SP, and PC values. The memory windows confirms that 81H old 10H verifying correct program execution. Thank you.
This process successfully demonstrates how to find the smallest of three numbers using a 8085 microprocessor. It makes a effective use of a data transfer, comparison, and conditional branching instructions to perform a logical decision making at a machine level. By using the CMP and JS instructions, the program checks the each value stored in a memory locations one by one and compared them to identify the smallest number among them. The smallest value is stored at a specific memory address, providing the correct functionality of the program. Through this experiment, we gained a clear understanding of how the 8085 microprocessor handles comparison and conditional jumps based on the status flags, especially the carry flag. It also shows the importance of using a registers like a accumulator and B for storing the immediate results efficiency during the comparison process. This process helps in developing a strong foundation for understanding decisions control structure. In microprocessor programming, it provides a practical knowledge on how the logical assembly instructions, the concept learned here, such as loading data from memory and performing the comparisons, updating register values, and using a conditional jumps. Here, for updating register value and using conditional jumps are essential for writing more advanced programs like sorting, searching, and arithmetic operations. In conclusion, the program not only achieves its objective of finding the smallest number among three values, but it also enhances the learns understanding of microprocessor architecture, instructions, executions, and flag-based decision making. It lays on solid base for exploring more concept on real-time applications in the field of embedded systems and low-level programming. Thank you.